system,
Which system?
grading system.
How about the grading system?
G. Yes, sir.
Okay, let us see. I think we'll get some official declaration, and then we'll decide about the class test. How about that 40%? I think let us wait for the official declaration. For now, since there is instruction for not taking any evaluation, not doing any evaluation, so let us see what is the final decision. Until then, I think I will say nothing. But according to our course outline, our second class test is 28th March. So there is a gap. Hopefully we'll get some direction before that. So wait until we get some directions from the authority. In that case, we will change ourselves accordingly. For right now, let us carry on our lectures, our learnings, and I think I will provide you an assignment shortly by next week. So assignment is okay. So you'll have some deadline to submit that. I think by next week I will upload that assignment in the LMS. Okay, so let me share my screen. So what about your change in the lecture delivery in English? Are you being aware? Are you being accustomed with that, or you are still facing some problems? So all of you are, I think you will get used to after some time, but that will be better for our career, for our if we want to do higher studies. I think this will all help. So it's all about the adapting to the situation, and hopefully now you can use your learning in the English courses now. Okay, so in the last class, what we have discussed, we have taken our first online class test, and then we have covered second part of section 1.4, that is throughput. We said there are two types of throughput. One is instantaneous throughput. Another one is average throughput. Instantaneous means taking the real transmission rate at a particular time in a day. Okay. For example, Sunday 10 a.m., Monday 5 p.m. But that is not very much representative. So if we take average, maybe weekly, maybe monthly, then that is more representative. So there is another one called average throughput. And then we have got some idea about how this rate actually comes from, or how we can calculate throughput. Okay. For that, we assumed a single flow of data so that it is understandable how actually a link transmission rate becomes a throughput. So in that case, if there are n number of links from R1 to Rn, we got that minimum of that all transmission rates of all links will represent the throughput. And we did one example, exercise 10, where there was 3 links with capacity 500 kbps, 2 megabits per second, and 1 megabits per second, and definitely the minimum is 500 kbps. So this is the throughput. And if we want to calculate the delay of transferring a large file, we'll use the throughput of the entire network, including all the links, and then we divide file size by the throughput, then we get the required time or delay. And then we have started section 1.5, that is very important part of any computer network course, learning computer networks, protocol layers. And we have discussed about OSI layer. We saw an example animation, right, where there were 7 layers in the end systems, and there were 2 routers in the middle, each of which work up to network layer, right? So then in the last part, we saw some comparative view of OSI and TCP/IP layers, and also we have discussed about the responsibilities of each of the 7 OSI layers. So that was the content covered in the last class. Any question before I start today's lecture? Anyone has any question? Okay, fine. So we will do some examples in section 1.5 today, and then we'll start our scheduled lecture on chapter 2. So we'll start chapter 2 today, and we'll try to cover the first 2 sections of chapter 2. So that is the overview of today's lecture. Okay, now let us just go through section 1.5. We said why we use layering, and I asked you to get some points from the textbook. So can anyone tell me why we use layering? Any particular reason? In short, using 2 or 3 words, why we use layering? Anyone? Rafsan, are you there? Ifat Haq Rafsan?
Yes, sir.
Do you have any did you get any point of why we use layering? No? You don't have time to, you didn't have time to. Okay. Kaushik Devdas?
Yes, sir.
Any point? Do you have any? Actually, I specified one reason specifically in the last class. Can you tell me what was the specified reason for using layering?
No, sir. I don't remember it.
Okay. Okay, no problem. I think we have lots of examples in our real life, like postal service, like air traveling. That is, the air traveling example is given in the textbook. Then when you go to a particular office, for example, passport office, right? Or any other office, government office, or any private office, you go for a particular service, you have to go to different desk, right? Although there is a service called one-stop service, so you get everything in one table. But normally what happens when you go for a work, you have to go to different places. That means the tasks, the entire tasks are divided into different layers, different responsibilities. Those have different departments. Like UIU, whenever you do some work like taking grade sheet or some other papers, you have to go to maybe to the department, then sign by the head, and then go to the registrar office. So there is a procedure, right? So that is, yes, any question? Okay, so there actually that is one example of layering, but it depends how many layers you need. In real life, there are so many cases where you do it in one layer. That is a very simple work, so you can go and then get service. For example, customer care of mobile companies. You go to a desk, you get your problem solved, and then you come out. So that is maybe one layer. But when they solve their work, maybe in the background there are multiple layers. So you can find out numerous examples in your real life. So if you just want to connect. In networking, the same thing. If you take that web browsing example, okay, if you take that example or any other example, we use networking, then in the background, the entire task, there are actually huge number of subtasks involved. So during the implementation, they have used some layering concept that we call the layering models. One is most theoretical model is OSI, and the mostly used practical model is TCP/IP. But that is where that layering concept comes. Now, what are the advantages? What are the reasons? One is, I said in the last class, one is what? One is dividing a complex task into simpler tasks. When you do some programming implementation, right? If the requirement is complex, then what you do? You solve the problem into smaller solutions, and then you just synthesize all the sub solutions to a final solution. You use functions, you use methods in programming, right? All are examples of layering. Now there is another reason, like specified in this example. You see different applications. There are telnet, there is file transfer protocol, there is HTTP for web browsing. All the applications work through some intermediate layers. If layering was not there, then every application must consider different type of media. For example, if you use coaxial cable, you have to implement one version of HTTP. If fiber optic, one version of HTTP. If packet radio, one version of HTTP. That is very cumbersome, right? So what is the function of these intermediate layers? They hide the characteristics of the physical media from the application layer. So that is another important reason. Layering enables us to work in an abstract way. So whenever Windows, we configure something in Windows, we don't want to think about, or whenever Microsoft develops Windows, develops a browser, new browser, they don't need to consider coaxial cable, fiber optic, packet radio separately, because that is covered by the intermediate layers. Which layer covers that? Actually, data link layer covers that. Okay, data link layer is the layer that connects through physical layer. So that is the second point. Any question? And there are other points like advantages, like modularity. Modularity means if you implement a system in modulars, in different functions, different modules, whenever a problem happens, right, you will only need to work with that particular module. Like you did debugging in a large program, you identified which function has error, you just change that function, and then you don't need to change all other codes calling the function, right? So that is modularity. Same thing happens troubleshooting. Whenever a problem happens, if the things are modular, it is easier to understand the problem. If the things are not modular, you have to go through everything in the machine, everything in the system before finding an error. And then functionality reuse. Definitely, if again, if a software company develops a software and that is independent of the routing means that is independent of the lower layer, that is network layer. In that case, the software development becomes much more easier. And also one function they already developed can be used by other system. So that is functionality reuse. So these are the advantages of using layering. And if
Sir, can you please explain the functionality reuse again?
Okay, functionality reuse. I think you have. If I give the example of in terms of programming, you did object oriented programming, right?
Yes,
So
sir.
you did inheritance. I think especially for computer science students, triple E students may not have done that. So that is like that. If we have already implemented some function, then for example, for a new system, you need that function. You can reuse that function, right? But
Yes, sir.
how can you reuse that function if the function is developed separately, modular? If it is defined independent of others, then you can use that. But if that is not independent, if it is part of an entire system, then whenever you create a new system, you have to develop from scratch. That is the point. Okay, like we will see. Okay, the best example is here. See, this is a common architecture of layering communication. See, layer 1 to layer 7. But in case of any layer, you can say one thing. Layer n gives service to layer n plus 1. That means lower layer always gives service to upper layer, right? For example, think about a organization. There is an MD, right? Managing director. There are some managers. There are some executives. So managers work under managing director, right? MD. Then executives work under manager. So executives provide services to whom? To the manager, right? Managers provide services to whom?
Executives.
To the MD. No, to the MD.
Oh.
Upper layer will not work for the lower layers. Lower layers work for the upper layers. See, just think that is common to all physical cases. Okay, so lower layers will always provide service to upper layers. Similarly, we can say the vice versa. Upper layer takes service from lower layer. So if a letter has to be prepared, then the manager will ask the executive, right? Executive will not type the letter. Executive will ask the operator. Operator works under executive, right? So this is the common procedure. Similarly, when we say OSI layers, all 7 layers, we can easily say that application layer takes services from all lower layers or directly from presentation. Presentation takes service from session. Session takes service from transport. Now, in case of TCP/IP, presentation and session is merged into application for simplicity, because you cannot differentiate presentation and session from a particular application. So if we understand from TCP/IP model, it is much better. So the application is dependent on service from transport layer. We'll see that in every chapter. Transport layer will seek help from network layer. Network layer will seek help from network access. But we will actually understand the OSI layer first. Then it is very easy to understand the TCP/IP model. And you can see there are some protocols: HTTP, DNS, DHCP, FTP. These are application layer protocols. Then TCP, UDP, transport layer protocols, right? And then IP address, IP version 4, IP version 6, ICMP, like ping. You use ping in the lab, that uses ICMP, network layer protocol. And the lower 2 layers, are data link and physical, is commonly merged into network access in TCP/IP, because these called network access. Why? Because these layers help us, enable us to access the network. How access the network? Receiving signals and then converting signals to bits, and then converting bits to bytes to a data frame. So the entire thing is actually described here. Okay. Now see this table. This actually summarizes all the things we have discussed in the last class and today's class. First of all, there are 7 layers in the OSI. Then you have to know what is the basic function of each layer. For example, application layer provides network services like email, like file transfer, like web browsing, like Skype. Okay, so application layer actually provides services to the user. Then presentation layer formats the application data to network specific format. For example, compression, encryption. Session layer set up and manage end-to-end dialogues, multiple simultaneous dialogues or multiple simultaneous connections. What is an example? Did you see any message like your session is expired anytime when you browse? Your session is expired. Maybe you are idle for 10 or 15 minutes and then you refresh or you just go to another page. Then it comes out a message. There comes out a message. Your session is expired. Did you see that?
Yes, sir.
Yes, sir.
Yes, sir.
But maybe you open 10 different websites, tabs, and maybe one particular website gives you this message. Why? Because that is user restricted. So you have to give a username, password, and the server validates that. And if you are idle for some time, for security reason, server locks you out. So in that case, when you again do something or refresh, client says your session is expired. Actually, not client says, it's server sends the message, your session is expired, so you have to re-log in. Now, out of 10 connections, one particular connection give you that, not the other 9. Why? Because the other 9 is not user restricted. Those are maybe some web pages, some papers. So you go through those. Okay, now who controls this? Which layer controls this? Session layer controls this. Session layer controls these 10 different connections separately. It keeps trace. So whenever a particular connection says something from the other side, it then conveys that message to the user. Question? Who has question? Shahadat, you have question?
No, sir. আগে স্যার মানে স্টেশনের যে ব্যাপারটা বলছেন স্যার আগে
হ্যাঁ।
স্যার আমাদের ইএলএমএস এরকম করতো স্যার এটা
Right.
সেশনটা স্যার ডিসেবল করে দিত স্যার
Right. Now still it is there, but the session time is increased. If the server says your session time is 10 minutes, then after 10 minutes inactivity, you will be logged out. If your server says your session time is 10 hours, then after 10 hours, your session will be logged out. So in that case, if it is 10 hours, then you get a whole day getting connected. So that depends on the server. Anyway, these different information from different connections maintained by the session layer. Then when I come to the transport layer, we have to pick one particular link connection. So for 10 connections, there will be 10 different connections, and for each connection, there will be separate transport layer. So transport layer responsibility is end-to-end delivery of message, end-to-end delivery of entire data from one host to another host, the entire message. See, what is the message? What is an example of message? Anyone? Is it a file, or it is a voice, or it is a video or audio?
So can be anything, sir.
Very good. Can be anything. So message is actually the application layer data. So it can be a text, it can be a voice message, it can be an entire file, audio file, video file, image file, anything. So we don't know what will be the size of the message. That's why transport layer will ensure, doesn't matter how large the message is, it will divide into smaller segments and then ensure all the segments are received by the receiving end, the destination, so that the destination can reassemble the segments to get the overall message or data. So see, the upper 3 layers, these are called application specific layers. They all has named data. That means protocol data unit. Protocol data unit means name of the data by the protocol in that layer. So we can call data, segment, packet, frame, signal, all are PDU, protocol data unit. But in a particular layer, you have to call using a name. For example, application presentation and session calls it data or message. But when you come to transport, it divides the data into manageable segments. So you call that a segment. And why we give a different name, that is actually a reason. For the upper 3 layers, every layer you can see, every layer adds its own header. Why? I have already specified, when source sends something to the destination, destination must know what to do. For example, when we send a letter by traditional postal service, not the email, by traditional postal service, we put the message or letter into an envelope and we write the address of the receiver right in front. So that address is not the real message. The address is the extra information that is needed to transfer the real message to the correct destination. So that is we call a header, and that is also in one sense that is overhead. Why overhead? Because we have to send that data along with the real data, especially in networking where we have to use the same line, same transmission rate for the real data and also for the header. So the less amount of header we send, the better is the utilization of the capacity. So that's why it is called overhead. And the entire process, every layer adds its own header by keeping intact the part of the upper layer. For example, presentation layer adds presentation header, but the rest is intact, application header and data. Session layer adds its own header and the rest intact. So this process, every time we add a header in every layer, this process is called encapsulation. And as we saw in the animation last class, when receiver reads the layer from bottom to up, every layer removes the header. Removes the header means actually it processes the header. So that is called decapsulation. Okay. Now, transport layer divide into segments. It adds its own header. Then transport layer sends each segment through network layer, because transport layer has no responsibility of deciding the path to which path the segment or packet will travel. That is the responsibility of network layer. So network layer ensures end-to-end transmission of not the message. See, the packets. What is a packet? A packet is a segment with network header. So if you keep an eye on the right column, you will have a clear understanding what is happening. So actually a packet is nothing but the entire segment plus network header. Agreed or not? Is it clear?
Yes, sir. Yes, sir.
Yes, sir.
Yes. Similarly,
Yes, sir.
network layer will not have any connection with hardware. So network layer will not be able to transfer even from your laptop to the next node. It must depend on some layer that is connected to hardware. What is that layer?
Data link. Yeah.
Data link. Right? Data link. So it hand over the packet to data link, and what data link does? It adds header and trailer. Now that is another question. Why it adds trailer? No other layer adds trailer. Okay, but I can say the frame is actually the entire packet plus frame, header and trailer. Yes or no?
Yes, sir.
Yes, sir.
If you understand this, then the entire concept of networking will be easier. Whenever you go to a particular mechanism, detailed mechanism, just keep in mind which layer I am working, and then it will be easier to understand. Okay, so now I can say a frame contains a packet, a segment, data. Correct or not? So if you capture frames, we can capture packets, segments, and data. So that's
Yes,
why packet sniffer
That's
tools
correct,
like
sir.
Wireshark, packet sniffer tools, they collect the frames from the physical media, and they display the contents of the packet, because frame contains everything. Anyway, so then data link layer has responsibility of transmission of packets on one given link. So see, the important thing, transport layer takes one message or data from one particular connection. Session layer manages multiple connections, but transport layer takes data from one single connection and then convert to segment. Network layer receives only one single segment, even not a message, not multiple segments, one single segment, converts to packet. Data link layer receives one single packet from network layer, convert to frame, and then we can say that frame is a collection of bits, and the hardware in data link layer converts each bit at a time to signals at the sender. Only in that point our machine data or signals from our machine exits to the next node.
Sir,
Yes,
sir, প্রত্যেকটা PDU এর সাইজ কি ফিক্সড নাকি ভ্যারি করে?
it can vary. It can vary.
ওকে স্যার, ওকে স্যার।
Good question. It can be actually, it is dependent on protocol. Sometimes it is fixed. For example, probably in ATM technology, every packet must be, for example, 53 bytes. So it depends on protocol, but it can vary. It is not always fixed.
ওকে স্যার।
Okay. So see, in this workbook, I have given so many examples, some from the internet, but this is only to make our concept clearer and clearer. So the same thing again described in this diagram. So just go through this. If you have any problem, just consult the text from the textbook. When your layering concept is clear, then network will be clear, network concept will be clear. Same thing in this diagram also. Here one more information, like host or any end system will have all 7 layers, but any intermediate system, it depends. In the intermediate systems, router works maximum network layer. So router is the device that connects different networks, but it works up to network layer, not beyond the network layer. Then switch, hub or bridge. Normally hub works at the physical layer, but some hub works like a switch. So in that case, switch, hub and bridge works physical and data link layer. So this is actually illustrated here, and we have already saw this animation in the last class. Any question?
No, sir.
Okay. Now we have the basic concept. Let us do 1 or 2 examples before moving to chapter 2, so that your concept will be clear. Let us do exercise 12 now, and others will be simple. I think you can solve yourself. I will give direction. Okay. So exercise 2 and probably exercise 12 or probably exercise 14. Let us do these 2 examples. Others will be easier if you understand these 2. So exercise 12 says understanding packet headers. Now, as I said in this diagram, you have to understand how this happens. You have to understand this entire table. Use your textbook if you have any confusion, but you have to understand this entire table I have already described, and use your concept in solving exercise 12. Now what exercise 12 says, see, there are 2 hosts. One is host 1 and one is host 2. So these 2 hosts are connected by this is a bridge. Okay, bridge is like a 2-port switch. You know, switch actually connects, switch or hub connects multiple end devices. But bridge is a switch have multiple ports, right? It can have 6 ports, 12 ports, 24 ports like this. But bridge was initial before switch. It is like a 2-port switch. So that's why it has 2 different ports. But you can think about bridge working same as switch. And there is a router in the middle. So a bridge connected with a router, and then to host 2. So host 1 and host 2 has two intermediate devices in the middle. Now assume that host 1 sends a message. Basically, you can think this message as a single small message that can be accommodated in a particular segment. So you can like this way. Anyway, so this message is application layer data, and you can see there are 1, 2, 3, 4, 5 boxes. These 5 boxes represents 5 layers: application, presentation, network, data link, and physical. Actually, physical layer has no header, so in that case this is actually not necessary, but these 5 actually represent 5 boxes represent 5 different layers. Why 5 different layers? Because you will find one term that is called IPS, Internet Protocol Stack. I think you will get, let me do exercise 12, and to solve exercise 12 we can define IPS means this is a theoretical layering concept that is needed to describe theory. So when we describe some networking mechanism, normally we don't say okay OSI or TCP/IP. Normally we use IPS similar, but it defines 5 layers only: application, transport, network, data link, and physical. So this is just a theoretical layering model, IPS. So that's why there are 5 boxes, right? So it represents 5 boxes in X, Y, and Z. We just make it clear that we can understand the diagram. So another thing, each host has IP and MAC address defined. I think I have described IP and MAC address, right? Let me review. I think during the animation I told you there are 3 types of data, 3 types of ID we need for communication. Okay, one is port number. Port number used by transport layer. Okay, why? To identify. We will make it clear in chapter 2 and 3. It will be more and more clear, but right now just keep in mind it used by transport layer. Port number used by transport layer to identify different applications. Okay, then 2 IP address, right? IP address used by which layer?
Network layer.
Network layer. Good. Network layer to identify, now not the applications, to identify hosts or devices in the network. And the third one is MAC address used by which layer?
Data link.
Right, data link layer to identify interfaces, network interfaces. We call that LAN cards, but actually a link can consist of multiple interfaces, but only the destination will receive that particular frame For that, we use MAC address. So see, port number, transport layer, IP address, network layer, MAC address, data link layer. These three you have to keep in mind to solve exercise 12. Now come back to our problem. Start by numbering the headers in the packet at points X, Y, Z. So the same packet travels through breeze, we rename it Y. The same packet travels through router, we rename it Z. So actually you have to keep in mind, this is the same message, same packet traveling through from H1 up to H2. But we give a different name to make it a distinguishable, okay? Each header should be assigned from number 1 to 5, okay? 1 corresponds to physical layer, C, and 2 corresponds to data link layer, 3 corresponds to network layer, 4 corresponds to transport layer, and similarly 5 corresponds to application layer. Now tell me, which header is added first by the sender? Application layer or physical layer?
Sir, application layer.
Very good, application layer, because user end starts from application. Okay, so that is clear. In that case, the first box on the left of message, if I say the numbering as 1, 2, 3, 4, 5, then 5 is the application layer header and 5 is added first. Is it clear?
Yes, sir.
Okay.
Yes, sir.
In that case, your answer should be like this. For example, if it says, okay, what is okay, let us do one particular example, then it will be clear. Okay, A, list all the places. All the places means all the packets, all the instances of the packets like XYZ. List all the places where h2.ip will be written. Okay, first thing, IP address will be written in which layer? Layer number? Layer number 3. See, layer
Yes, sir.
3, layer
Network
3
layer.
correspond to network layer. So since we are numbering, using numbering here, so IP, first you have to decide H2 IP means first IP address. So IP address is written in layer 3. So
Layer
in any packet, IP address will be at layer 3. Now the question is, H1 will add H2.ip as the destination IP, right?
Yes, sir.
So
Yes, sir.
in which of the packets that destination IP will be copied? Which of the packets it carry H2 IP? Only X or XY or XYZ, all the packets? That is the question.
Sir, XY.
Sir, প্রথম কোথায় লেখা হয়েছে নাকি কোন কোন জায়গায় থাকবে লেখা?
Okay, all the answers, for all the answers, you have to make sure your answer will contain X, Y, Z all. If it is only in X, then your answer will be X. If it is also in Y and Z, then your answer will be X, Y, Z. So h2.ip will be added to layer 3 in X, right or wrong?
Yes,
If I say right, okay, if I say H2 IP is the destination IP, so that will be written by H1, and since it is IP address, that will be written in layer 3. So X layer 3 will contain IP address of H2, right?
Yes, sir.
Okay, now we can write it like this. A, answer will be X, comma 3. Is it clear? That means packet X, layer number 3, box number 3 means layer number 3 will contain h2.ip, right?
Yes, sir.
Okay, now it travels through the breeze. Now X becomes Y. The question is whether or not h2.ip will remain same in Y. Yes or no?
Yes, sir.
Yes. Why? Because breeze will work data link layer. Data link layer is layer 2. You saw in the animation. That's why I have specified why there were 2 separate boxes in data link and physical. Did you remember?
Yes, sir.
I have specified that point. But in the
Yes, sir.
network layer, the box was not divided. Why? Because network layer is implemented in the software, and whenever a packet travels from source to destination, the software address, that means the IP address, will never change. But for every link, the MAC address will change, right? So keep in mind. Now, Breeze works up to layer 2. Layer 2 means up to MAC address. So Breeze will not change IP address. Even router will check the header, network header, but even router will not change the network header. You can go through the animation again and again, and you can observe this. That will be used in this example. And this example is very important, because if we are clear here, then our concepts in the subsequent chapters will be very much clear. So that's why I'm just doing this exercise in the class. So in the Y, again, it will contain h2.ip in 3. Anybody has any confusion so far? When it goes through router, it becomes Z. In Z, in layer 3, will h2.ip be there? Did you get my question?
Yes, sir.
It will be there again.
Yes, sir.
Okay, why? Because IP address will not change throughout the journey from source to destination.
Yes.
Sir,
Yes,
so IP address is always fixed, right, on a device?
right.
Okay, sir.
We can change, but until we change, that is fixed.
Mm-hmm. Yes,
So
sir.
when data communication happens, that is fixed. And the intermediate devices, by default, there are exceptions. There are some exceptions, but for now, we'll not go for exceptions. We'll learn the rules of basic. So in that case, during the journey from one host to another host, the IPs will be fixed, and also the IPs put in the layer 3 or network layer of the packet will never change. So that's why it will be in the X, it will be in the Y, and also it will be in the Z. So that is the answer of A. Any question or any confusion? Okay, let us do one or two more, so that if I think many of you already also has some confusion still, but it will be clear. Okay, let me do D first. List all the places where r1.mac is written. Okay, before that, let me ask you a question. If I change the first question A, if I put h1.ip, list all the places where h1.ip is written, will the answer change? What do you think?
স্যার আমাদের কি সোর্স আইপি কি দেওয়া থাকে স্যার?
Right. So make sure you understood source IP and destination IP. Both are given when a packet is created.
ওকে স্যার.
See, source IP is the source of H1. Otherwise, destination will not know from where that packet comes, right? How can it reassemble? So source IP and destination IP, both will be the content of layer 3 of a packet. So that's why the answer will not change. Is it clear?
Yes, sir.
Okay. Now let us go to an example of MAC. Suppose list all the places where r1.mac is written. What will be the answer? Okay, please put your answer in the message box. No problem. You can do it wrong. No problem. Ishtiaq Ahmed, are you there? Ishtiaq?
Yes, sir. I'm here, sir.
Okay, what is the answer? According to you, R1.Mac. Okay, anyone, just say one packet where R1.Mac must be there. Any idea? Amanta?
Sir, I have to analyze sometimes.
Okay.
Sir, Macটা তো নেটওয়ার্ক লেয়ারে অ্যাড হবে না?
No. What I said, see? MAC address used by which layer?
Data link layer.
Oh, okay, sir.
Right. You have to keep
Yes,
in mind.
sir.
Okay. Amanta, are you there? Amanta Hussain? Okay, no. Abir Reza? Abir? Shahadat?
Yes, sir.
Oh, you put the answer already? Y2Z2. Very good, Shahadat. Answer is correct. Rifaz. First thing.
Yes, sir, I was confused, sir.
Okay. Now it's clear?
Yes, sir.
Okay. Because first you have to think about which layer actually puts that particular address. So MAC address always put by data link layer. So it will be definitely layer 2. Now the next question is which instance of the packet will contain that, because see, X has no connection with R, right? So X will put, so again in the layer 2, source MAC and destination MAC both must be there. So for X, source MAC will be h1.mac, right?
Yes, sir.
And destination MAC will be b.mac. And for Y, source MAC will be b.mac, right? Destination MAC will
Yes, sir.
be r.mac.
R.mac.
Actually, it should be r.mac. There is only one router, so R1 and R is the same. Don't confuse. It should be the same. So r.mac will be the destination. For Z, r.mac will be the source. h2.mac will be the
Destination.
Now see the answer. So for Y, r.mac will be there as source. For Z, it will be as the destination. But we don't need to put, like specify source or destination. Just we need to specify which packets and which layer the header will contain the r.mac. So it will be Y and then layer 2, and also it will be Z and then layer 2. Okay. Okay, let me do one more. List all the places where r1.ip will be written. This is a little bit different. That's why I have to show that. That is B. Anybody has any answer? So D is okay. And what will be the answer? Okay, now first thing. What
Sir,
we, okay. Okay,
sir,
tell me.
Y3Z3.
Y3Z3. Okay, now any other answer? Because I want everybody to storm your brain before I give the answer, because it is a very important concept. First thing, in the source IP or destination IP, you can put only one IP address, and as I said, it will never change during the travel, right? So if you put r1.ip anywhere, you have to remove either source or destination, right?
Yes, sir.
You cannot remove source because source is always h1.ip. So you have to remove h2.ip. You can put r1.ip, but in that case, what about the final destination? It will be lost.
Yes, sir.
Okay, next, second point. I think all of you, maximum, you are doing computer network lab, and you have one keyword called what? Default gateway,
Yes, sir. DNS.
right? What is the default gateway? Is it an IP address?
Yes, sir.
It's a root, sir.
No, default gateway is not the root. Default gateway is an IP address. Which IP address?
Sir, of the router.
Very
Most
good. Reverse. Right. Router's IP address. Router's IP address. So R.IP or R1.R and R1 is same in this question. Don't be confused. It should be R actually, because in the diagram it says R. So R.IP is the default gateway. So you have completed lab 1. In the lab 1, what you did? You recorded the IP address, subnet mask, and default gateway from a particular PC, right?
Yes, sir.
So all the PC, all the hosts in a network will have the same default gateway, yes or no?
Yes, sir.
Yes.
Yes, sir.
And that is the IP address of the router. So where is that router's IP given? That is given in the host. Why? Because if destination is in a different network, then we have to first send to the router. How we can send to the router? The PC must know the IP address of the router. So that is the default gateway. Now, that IP address is actually specified in the Windows or Linux in the machine. That is not written in the packet. Get my point?
Yes, sir.
Yes, sir.
And it will be clear when we complete chapter 4 and chapter 5. It will be more clear. But right now, just I am giving you some logic. Why our router's IP will never be in a packet? It can be in a packet when you ping the router's interface. When you ping the default gateway, that means the ping packet will contain the destination IP as the router IP. Only in that case, router IP can be at the destination IP. But when we
Sir.
send the packet to a particular host, then host IP will be the destination IP and router's IP will not be in the packet. Yes,
Sir,
question.
কারণ হচ্ছে এটা হোস্টে কনফিগার করা থাকে, তাই না?
Right, right, very good.
Sir.
It is configured in the host. It is not written by in a packet by any device. It is configured in the device itself.
Okay, sir.
Okay, so if that is clear, then what will be the answer? The answer will be none. Right? Because no packet will contain R.IP here. Why? Because the destination is H2.IP. So the destination IP will be there and router IP will be only configured in H1. Not the packet of XYZ. Is it clear? So when you say H1 IP, H2 IP, fine. But when you say router IP, that will not be in any packet. That's why answer will be none, or you can write like this. Okay, one more. If list all the places, please put your answer in the message box. I will not give the solution right away. List all the places where port 8888 is written. F. So what will be the answer? First of all, port number is written in which layer?
Transport.
Right. So give the answer. Please try. Everybody, please try. Mashuk Alam, are you there? Mashuk Alam. Sakib Hussain. Tanvir Hassan. Al Shariar.
Sir, Sakib Hussain.
Sakib Hussain. Al Shariar. Rakibul Islam. Rakibul Islam. Taki Yasir.
Yes, sir.
Did you get the answer? Please participate. Just your answer may be wrong, no problem. If you participate, your study, your concept will be clear. No answer yet. I have already put a hint, right? So it's layer 4. Rifas. Okay. X4, Y4, Z4. Any other answer from anybody?
স্যার একটা কনফিউশন আছে স্যার কোশ্চেনটা নিয়ে।
Okay. Which confusion?
স্যার রিটেনটা মানে কি যে কোন কোন লেয়ার নতুন করে লিখে দিচ্ছে
No, নতুন করে,
নাকি
not নতুন করে. It's a in which packets it is written. That's it. First
হোয়াটস
time.
ইন হুইচ প্যাকেট
Right.
এক্সিস্টস এরকম
Right,
কিছু একটা
right,
স্যার।
exists, same thing.
আচ্ছা আচ্ছা স্যার।
Actually, when it is written, then it exists, right?
ইয়েস স্যার। ওকে স্যার।
I think Rifaz, you are correct. Taki, it will be also Y4 because why not Y4? Because transport layer header will not be used by any intermediate device, right? Because it works maximum network layer. So transport layer header will never be changed in the middle. So that's why it will be in all cases. So our answer will be like the first one, but in this case it will be at layer number 4. Okay. Why? Again there are source port number and destination port number. So if you think about destination, the answer will be the same. If you think about source port, the answer will be the same. Okay. Any question, anybody? Okay, I think the rest of the questions I give you as the homework. Homework means you will do at home because the main concepts should be clear. Now, exercise 14. I will just only give directions here. Then I will discuss about the solution in the start of the next class because I cannot give more time on chapter 1 today. I will start chapter 2. So just exercise 14. What exercise 14 says? Consider a message or data of 150,000 bytes that must be sent from host A. This is host A. Sorry, this is host A, and this is host B. As a succession of PDUs. Succession of PDUs means definitely this message will not be sent entirely. It will be divided into segments by the transport layer. So how we can divide and what is the effect? That is the idea of this question. Make a header containing 200 bytes. So if we divide into PDUs, every packet or segment will have header 200 bytes, okay, of protocol control information. That is the header, and a fraction of the message. So rest of the message, each PDU is received, stored, and forwarded by 2 packet switching nodes. These packet switching nodes are in the middle, this one and this one, but that is not a problem. Now consider the 3 scenarios. These 3 scenarios actually depends on how we divide. If we give 10,000 bytes in a single PDU as data out of 150,000, okay, then one solution. Then we can give, okay, 2,500 bytes, or we can give 750 bytes. Now it says which scenario leads to the shortest latency. Shortest latency means what? Least delay for the complete reception of the message. Complete reception means all the individual PDUs should be received by the receiver. Now, how we can solve this question?
স্যার 3 নাম্বার সিনারিওটা হতে পারে।
Shortest time? Okay, okay, let me just give a direction. Okay, exercise 14. Exercise 14. Exercise 14. Okay, first of all, we have to find number of PDUs, right, for each case. So number of PDUs for case 1 will be what? Will be 150,000 divided by 10,000, right?
Yes,
That means
Yes, sir.
150.
150.
150.
So if 150, then header or overhead, it is, we can call it overhead because it will be the extra data, will be 150 into 200, right?
Yes, sir.
That means what? That means 30 and then 000. So 30,000 bytes. So we can then find out total data transmitted will be message plus overhead, right?
Overhead.
Message plus overhead. So how much will be? 180,000, right?
180,000.
Bytes. Similarly, you can find for 2 and 3. This is your homework. Find for 2 and 3. Now, what do you think? Which one will have most data transmitted?
So number 3, sir.
Very good. Number 3. The more packets we create, the more header must be added, and the more number of bytes must be transmitted. And the more number of bytes transmitted, the more time delay will be required, right? More latency will be there. So
Yes.
actually number 1 will take least time. You don't need to find out the time. If you find out the total number of bytes, you will see number 1 will be least number of bytes. Why? Because it will create least number of packets. So having said that, it depends on a particular protocol, because if a protocol says I cannot carry more than 750 bytes, you have to use 3. So if you want to compare 2 protocols, you can think about this type of interpretation. Okay, so this example actually represents this. Is it clear? So number 1 will take least time. That means less number of packets, less overhead, less delay. Clear? So please
Yes, sir.
complete it before the next class. If you have any questions, we can. I will give first 10 minutes in the next lecture, and there are some questions already. Some of the questions solved in the class already, and some of the question you try and then discuss about the problems in the start of next class. Now the remaining 20 minutes, I think I will use 15 minutes at least to introduce chapter 2. Chapter 2, for chapter 2 we have 4 sections. Okay, let me start. So this application layer will cover section 2.1, 2.2, 2.3 and 2.4. So these 4 sections will be covered in chapter 2, and probably we cannot start section 2.2 today. We'll try to just give some overview, that is principles of network application, section 2.1 by today. Okay, now in chapter 1, what we did, we have a basic understanding of different types of networking concepts. 2 technologies, one is packet switching, one is circuit switching. Then we have concentrated on packet switching, and throughout the semester, rest of the semester, we will actually concentrate on packet switching. We are not dealing with circuit switching in this course. As you know, even packet switching is prevailing in all over the place. Even in cellular network, mobile network, packet switching is coming out. circuit switching is being squeezed down. Okay, so for internet, it is very important to understand the packet switching concept. Now, from this chapter onwards, we will go through more detailed concept or mechanism of every layer: application layer, transport layer, network layer, data link, up to data link layer. Will not cover very much of physical layer in this course. So probably we'll go to up to data link layer. So now start application layer. As we said, application layer works at the network edge. So these 4 sections we will cover: principles of network applications. Then the mostly used, I think all of us, we have used web browsing a lot. So how web browsing uses the protocol HTTP. And then we'll also cover email. Some protocols, SMTP, IMAP, and POP is used there. And then finally, the protocol without which internet will not work, that is the domain name system, or DNS. We'll cover that in this chapter. What are our goals? Conceptual and implementation aspects of application layer protocols. As we said, application layer takes services from transport layer, right? So
Yes.
even to understand application layer, we need to understand the transport layer service models. And then to architecture, already we gave some basic idea about client server and peer-to-peer in chapter 1. We'll go to details of different protocols, mostly client server paradigm, not very much peer-to-peer, because for the lack of time, we will not go to peer-to-peer architectures. Then we learn about protocols: HTTP, SMTP, IMAP, DNS. Programming network application socket API. In fact, in theory class, we have to skip that. But in your computer network lab, you will have one full lab on socket programming concepts. That is very important in terms of software development. Okay, now when we think about a network application, these are written on end systems. And first of all, in chapter 2, we are thinking about network edge, because we are communicating from one end system to another end system. And that's why users interact with the end system. So we need to write programs that run on different end systems that communicate over the network. For example, web browser, we used a browser, but definitely we have a corresponding server software in the server with which browser will communicate. But we don't need to write any software for the network core devices, that is the intermediate devices, as users will not use intermediate devices for using applications of network. So that is one thing. And for this, the communication will be like this. So we are in the diagram, we just disable the intermediate devices to show that in application layer, we just assume lower layers are working fine, intermediate nodes are working fine. So our concern is how applications can communicate between themselves. And based on that, already we have discussed this. There are 2 paradigms, 2 architectures in network edge or in the application layer. One is called client server paradigm, where server is always on, like Facebook server, Yahoo server, Google server, they are always on. We always get the servers 24 hours a day, 7 days a week, all over the year. And also server must have a permanent or fixed IP address, because clients always needs to get the server in fixed location. And often the servers are used in data centers for scaling, like, you access UCAM, right? That is in our data center at UIU. And for the clients, they communicate with the server. Client may be off and on and off. They can intermittently connect it. So in that case, they can have, client's IP is not necessarily fixed or permanent. That IP can be dynamic. Like at UIU, when you use Wi-Fi, if you check your IP address, you'll get that every time you might get different IP address. One particular characteristics of client server paradigm is there is no direct communication between clients. Clients will communicate through the server. For example, HTTP, IMAP, FTP, like file transfer protocol, we'll read in more details later. And then there is another one called peer-to-peer architecture. Definitely there is no always on server. So there is no dedicated server. Any host can be simultaneously act as a client, as a server. And the advantage of this system, it is self-scalable. So new peers can be joined, can leave, doesn't matter. And peers, but the management is complex. The disadvantage is its management will be complex. And for example, peer-to-peer file sharing, there is so many examples like torrent, but there are some hybrid systems like instant messenger, Skype, where there are some properties of peer-to-peer, some properties of client server, because they have dedicated server. But again, using those instant messaging software, we can directly send message to the client. Okay, now irrespective of client server and peer-to-peer, we have to have some processes running in a host. Like when you browse internet, we have to have a browser. So what is a browser? It's a program. It's a process. Then it communicates with whom? It communicates with the corresponding web server, maybe in the Facebook, maybe Google. So that is also a program running or process running. So application layer actually deals with communicating with process, but there are two types of process communication. One is within the same host, two processes communicate. For example, if you copy a text in MS Word and then paste in maybe MS PowerPoint, this works, right? But it is actually within the same machine. You cannot copy in a machine and you cannot paste in another machine. That will not work. So when we say within the same host, two processes communicates, this we call inter-process communication, and this is handled by the operating system. So operating system uses some common memory where it puts the copy text, and then whenever we paste, it just gets that common text and then paste. It is possible because the host uses the same memory. That's why. But when you communicate in between different machines, it will not work. In that case, how communication happens? The only way for communication is exchanging messages. That is what we have already discussed several times in networking, in communication. Like for human, even if without saying something, we can exchange messaging by gestures, by any other means. So exchanging messages is something we need when we communicate in networking, and when we communicate messages between two different machines, only then we can call it a network. Okay. So in that case, there will be a client process that will initiate the communication, and there will be a server process that will be run first and wait for the request from the client and then serve. These are called server processes. Like in this example, and now how they communicate. See, there must be an interface between application and then the lower layers. That is where the transport layer comes. The transport layer take data from application and then send data with the help of lower layers at the sender. And at the receiving side, transport layer receives data from the lower layer and then hands over the data after reassembling, creating the original message, then hands over the data to the application. How that happens? That happens using a concept called socket. So simply, socket is analogous to a door. So application gives data in the sender. How? Socket is something related with memory. So application puts the data in the memory, and then transport layer processes data one by one. At the receiving end, transport layer puts the data in the memory, and then application layer receives data from there. So socket is a programming concept that is actually related with some memory that enables, communication between two different processes residing in two different physical machines. Is it clear now? Any question? So this is a very important scenario we have to keep in mind whenever we need to understand any communication in application layer in networks. So these are two different machines, and see in the middle, what is in the middle? Internet. Internet means what? Internet means some intermediate devices connecting with the physical media. But we can think about application at the source is logically directly communicating with application at the destination using sockets. And for that, I think already we have described in the solution of exercise 12. See how that helps now. Because for that, we need to understand the addressing processes. Since a machine, any question? Okay, since a machine has one IP address and multiple applications, please mute yourself if you don't have any. Mute, please. Okay. So if you have a machine that has one single IP, but it can have multiple applications. So that's why IP address is not enough. We need to identify each process, each application. For that, we have to use different sockets, and then we have to identify that sockets, because a machine might have 10 different connections. So each connection will have separate data. That is why when you download 3 different files at the same time from the same server, no data is overwritten, right? Each downloaded file is good differently. How? Because they use different sockets. Now, for every socket, you have to identify that application through that socket using a port number. So ultimately, when we want to identify a server, we need 2 identifications. One is the IP address of the server, and also what? The port number on which the socket is listening. Is it clear? Any question?
Yes, sir. Clear, sir.
Okay. So, okay, last thing, I think next thing is what an application layer protocol defines. We have already know the protocol definition using 3 keywords. Can you remember? What were the keywords?
Order, format, actions.
Very good. Format, order, and actions. But that was a generic definition of protocol. Now, when we come to application layer, we need to redefine that definition, what the application layer protocol defines. So now we can say there are 4 things. First one, types of messages exchanged. For example, HTTP, doesn't matter how much time you browse, it only exchanges 2 messages, HTTP request and HTTP response. Then what is the syntax? That is the format. Syntax means the format. What fields in message and how fields are delineated. That is format and order. Now, one other thing is the meaning. For example, IP address is 32 bits. You cannot give a 34-bit IP address. It's 32 bits. So meaning, what meaning of the information in the field, it is called message semantics. And the finally, rules means the actions. When and how processes send and respond to the messages. So there are some open protocols defined by RFC, request for comments. For example, if you search Google for HTTP, you will get a document of 1,000 pages. All the rules and definitions are specified there using RFC something. Maybe it is 1, 8, 9, 10, like this. Then there are some proprietary protocols that is not publicly available, like Skype. They don't disclose their protocols publicly. Okay, so these are the things an application layer protocol defines. Okay, I think okay, this is the last slide. Let me discuss. Okay, now as I said, application layer depends on transport layer, right? So transport layer gives services. How you will decide, how an application layer decides what type of service I will get. There are 4 points. First one, data integrity. Data integrity means no loss of data. So that is first point. Second point is delay. Less delay required or delay is not a matter. For file transfer, data integrity is first. No loss of data. But some delay is okay. For multimedia, for voice, delay is first. Less delay must be to be effective, but some data may be lost. So there is a trade-off. Then throughput. We have read throughput. So throughput, some applications need minimum throughput. So it cannot be less than 1 Mbps, some applications. But some applications like file download, it is elastic. It will download first if there is more bandwidth. If less bandwidth, it will download with more time, but no problem. And final one, security. Some applications needs encryption, data integrity must, like HTTPS or normal HTTP. Okay, I think I will stop here. We are almost at the end of the time. I will stop here. So we'll continue from the next slide in the next class. Any question? Any short?
I have a question.
Okay.
So I have a confusion about like scaling data. Like, what is that? Is it like you're transforming the data so it fits like within a specific scale or something? I'm not clear about that.
No. Scaling means like that client server and peer-to-peer, right?
Mm-hmm.
Okay. In that case, scaling means suppose we are developing a system for 100 nodes, right? 100 devices.
Yep.
Now, if the devices becomes 10,000, what will happen? This is more scalable. Is it scalable? If it is scalable, then for 10,000 it will work.
Oh,
If it is not scalable, then when you increase tremendously, it will not work. So for internet, scalability is a big issue.
yes.
So in that case, scalability matters. So for client server, it is better. For peer-to-peer, it is more scalable because anybody can join. For client server, it is not scalable because like in our SSC HSC result, right? For that 4 or 5 hours or 6 hours, nobody gets connected. Actually, somebody gets connected, but there are, for example, 10,000 connections possible, but 10 lakh people tries. So that is not scalable. So this is the definition of scalability. How we can solve that? We have to have more and more servers to support scalability. That what is done by Facebook and Google. Okay.
Yes, sir. Thank you.
Okay, thank you. Let me take the attendance. Abdullah Al Rifat.
Yes, sir.
Response first, okay? Enamul Haq.
Yes.
Enamul Haq. Imam Reza. Rokunuzzaman Khan.
Yes, sir.
Laila Ishrat.
Yes, sir.
Farah Farzana.
Yes, sir.
Okay, Fazle Rabbi. Fazle Rabbi. Priyobrato.
Yes, sir.
Ali Ahmed.
Yes, sir.
Okay, for those I don't call, you are present, okay? Don't worry. Khurshida Jahan. Samir Ahmed.
Sir, chat box se dise sir, Khurshida Jahan.
Okay, Samir Ahmed. Mahmudul Hassan.
Present, sir.
Fahim Shakil. Abu Sajjad.
Present, sir.
Nibirujjaman.
Present, sir.
Sadman Sakib.
Yes, sir.
Adnan Kobir.
Yes, sir.
Okay, Taki present. Shahadat present. Rakibul Islam. Al Shahriyar.
Yes, sir.
Tanvir Hassan.
রাকিবুল ইসলাম কি 181 তাহলে স্যার ও নামাজে গেছে
181002. Okay.
হ্যাঁ নামাজে গেছে
Okay, Tanvir Hassan. Mashuk Alam. Sabbir Sarkar.
Yes, sir.
Abrar Sadiq.
Yes, sir.
Ishtiaq present. Abdullah Al Mofil.
Present, sir.
Mahfuzur Rahman Sifat.
ইয়েস স্যার
Shafiqul Islam Nirob.
Yes, sir.
Amanta Hussain. Abir Reza Pial.
Yes, sir.
Khalid Ridwan.
Yes, sir.
Shahariaz.
Chat box se
Chat
Okay,
box se dise.
Okay, Tahmina Tanjin.
Present, sir.
Mohammad Mahfuzur Rahman. Mohammad Mahfuzur Rahman. Fazila Nobi present. Ashrafun Nahar present. Shifa Chaudhuri.
Yes, sir.
Misbahul Alam.
Yes, sir.
Yasir Arafat.
Present, sir.
Shudip, okay. Shudip present. Abdul Rahim.
Yes, sir.
Miraj Farooq.
Yes, sir.
Anu Abdullah. Abu Abdullah, sorry. Abu Abdullah. Khondokar Shravan.
Yes, sir.
Shah Alam.
Yes, sir.
Imtiaz Hussain. Imtiaz Hussain. Rifaz Nahian present. Kamrul Islam Tushar. Dihan
Present, sir.
Pathan. Kamrul Islam, are you there?
Yes, sir.
Okay. Dihan Pathan.
Present, sir.
Abu Kibriya.
Yes, sir.
Bidhan Chandra.
Present, sir.
Anyone else? Not registered yet?
Sir, Mahfuzur Rahman.
Mahfuzur Rahman Sifat. Or Muhammad Mahfuzur Rahman.
03118258, sir.
Okay, Muhammad Mahfuzur Rahman. Okay, fine.
Network problem.
Okay, fine. No problem. Imtiaz Hossein Shobhan.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay, anyone else? Okay, thank you very much. See you next class. Shakawat Hussain. Please put your ID and name in the message box, okay?
জি স্যার, স্যার আমি লেট রেজিস্ট্রেশনের কারণে স্যার আপনাকে স্যার মেইল দিয়েছিলাম স্যার। স্যার বাকি